Section 7.6, example 2, writing a system of equations for an augmented matrix form, from an augmented matrix form. Find the system of equations from the augmented matrix. So exact same thing that we had earlier, only we're going in the opposite direction. Here we have an augmented matrix, and we want to find what the system of equations are. And zooming in here, the first column is our X column, the second column is our Y column, third column is our Z column, and the last column is our constants column. This vertical line here separates all the variable coefficients from our constants. So coefficient is just the number in front of our variable. So that's what these are. And lastly, each horizontal row is what we're going to call this. Each row is a separate equation. So let's start with this first equation. This first equation has a 1 for the coefficient of x, a -3 for the coefficient of y, a -5 for the coefficient of z, and a -2 for the constant. So let's write that down. So 1x, and because it's 1, we really don't have to write that one. So we could just write x, -3y, -5z, and that's equal to a -2. And now for the second equation, we're writing those coefficients. Again, this is a coefficient for x, for y, for z, and this is our constant. So we have 2 for the coefficient of x, a -5 for the coefficient of y, a -4 for the coefficient of z, and a +5 for the constant. So here we have 2x minus 5y minus 4z is equal to 5. And this last one, now that we're kind of experts on this, we have our x, y, z coefficient, and then our constant. So this is a -3x plus 5y plus 4z equals 6. And there we go. We have our system of equations. If you have any questions, please feel free to ask. Otherwise, bye.